Hello, this is Alex and you are watching Animate Magic. Today we will be taking a look on this hair revitalization effect that was posted on Houdini artist group recently, and I will try to recreate this effect as closely as possible in 3D and Houdini. And thanks to Jan Bregula and Luis Manjares for posting their solutions. I've learned a lot from insights from the guys. They have many very interesting techniques. Like you can see the senior artist in there, I suppose. So I will be mentioning that during the tutorial. And this effect, apparently, it's not that complicated. But once I started to actually shade this and try to get it to look right, it ended up being quite complex. So I will be getting in all of these subtleties during the actual creation. And let's just proceed to Houdini without further ado. And if you would like to see Lewis's solutions, then just go to Houdini group, Houdini artist group, and then in the files you can see this, basically this post that contains all of that. So yeah, thanks again, guys, and without further ado, yet again, let's just try and do it. So this is what I came up with in Houdini, and both of these setups. This is after the update from the second update from Lewis, that we get this new technique for actually doing displaced Voronoi scales. I did not know that I could displace Voronoi scales in this way, that you would have to do some kind of looping or something like that. And I also tried to do the scales with booleans, structuring, but the pieces were too irregular and it didn't work. So I stayed with Voronoi, but with this you can actually get some nice organic shapes and they really look very interesting, I think. And the setup is fully procedural, so mostly procedural. So all of these droplets got rescattered and all of the stuff worked. So this will be basically what we want to get in this after we finish this. There is the attribute that is hiding the scales or basically undistorting them. Then we have the golden lines, they start to grow, and then the ribbon is flowing around the hair. But yeah, this is not finished, so I'll like end up rendering it until the end. I start in this empty scene. Basically, I just have my LOP network, nothing special in here. I just made this so that I don't need to create this every time. We just have a dome light in here, some sub import, and then here we'll place our materials. And I import cameras from subs, which I don't really need to do because I will not be making any cameras. I will just use this camera, this cam default, and yeah, let's just drop down a geo node. I should be probably getting it on because this will be a lengthy tutorial, but yeah, it is what it is. Okay, here, renew. And all of this effect will be contained in this geo node, but yeah, bear with me. So we are starting with curve. A curve, just like that. It can be a polygon curve or not. I'll drop it from the top around the 0 point, and I'll just place it here, and then here, and then maybe here. That should be enough. I will resample it. Don't mind my writing, please. I always make silly mistakes when I'm looking for nodes. This will be O1 and treat it as subdivision curves. So we get some nice nice curved surface. I would also like this to be a little longer. We can use the keyboard shortcuts to edit this initial curve. I just press F to enable edit mode and just place them around -1 to 1. Okay, after this, next step that I do is sweep it. You can't have a proper setup without at least one sweep node. Of course you can, but sweep nodes are amazing. So this thing and cross section, I want it to be a round tube, and you can see where this is going. We'll be having this hair thing, and yes, I would like some more resolution on it, maybe like 24. And this can stay as a 0.1. This should be alright. Okay, and apparently this camera is almost, this is a camera that I created in VOPs. So basically we'll be doing everything to match a camera. So I'll just name this hair broken. And I will import this as it is right now to VOPs because I want to set up that camera so we can always know where we want the effect to happen and don't spend too much time just stumbling something that will be off camera anyway. So this will be out here and I'll import it here, out here. Load as reference. I don't know if this is what this is doing exactly, but I recall someone said that it's making it a little faster, so that's what I'm pressing it, and it didn't break anything and up until now, so I guess that's okay. And just use the camera, turn this off, maybe make the background dark so that you can see better. And okay, so leave this. I want it to be like this. And maybe a little on the, I want to this thing to happen diagonally, maybe like this. Yeah, we'll say. Okay, I'll have to, so let's drop down a lob import cam, and here, so let's select this. I will just select my render, and here in the primitive path, I'll just select the camera. And I do that because if I would end up doing some kind of lob edits in this part, then I am importing this node, so all of these edits will be eventually incorporated in this lob. So I'll call it lobcam and look through this camera for the most part to just preview the effect right from the start, because we don't need to spend time doing some stuff that is off camera anyway. Okay, so right off the bat, right now, we need to do the fracturing. So what we'll need is a Voronoi fracture. And this is basically just redoing the setup from Lewis. So I will resample this this curve a little differently this time, maybe some less points. It will be maybe 0.5. Let's see it. And yes. What we also need is we need is we need to add some variation to the position of those points. So I like using VOPs, so I'll create a VOP for it. So let's add VOP and put it here. I'll call it Distort Points, and in here we'll drop some very simple stuff that is just so I'll do a random and base it off point number and add some some parameter. That will be the seed for so we can change the output for randomness, basically. Seed. So I'll do point number plus seed, make a random number out of that, and then we'll fit that number from 0 to 1 range, because this is what the random gives us, to -1 to 1. But what we wanted is not float, we want a vector, so let's do -1, -1, -1. And then this is basically what we need, but in this secondary sample, which should be here, we need to enable tangent U, and in this first one we need to enable curve U, because those attributes are super important. Curve U is an attribute that goes from 1 to 0 along the curve, and tangent U is just a vector that points from this point to this point, and from that point to this point, and from this point to that point. And you get the idea. And we can use that tangent U with bind. I'll bind tangent U, and that's a vector. And that vector will be using a cross product of this vector and the tangent U, basically. So we have some random vector that is cross produced with this tangent U, which gives us basically a vector that is perpendicular to these two. So one is pointing here and one is pointing wherever, and we are getting one that is perpendicular to both of them. So I'll just add to position this stuff and export it as position. So let's just see what it does, maybe, if it does anything. And it does. It basically creates this very, very random offset for all of our points, but they are not totally random because they are just getting offset in these two in this, like, not in the tangent U, they are not moving front and back, but they are moving everywhere else. Oh, this is obviously too much, so I'll multiply that by a part parameter. That will be the scale for it. This will be scale this or something, and this will be scale disp. Yeah, so here now we can have some nice controls. We can first of all decide how much displacement do we want, and with this I can control basically where on this curve it is. It doesn't really look like it's changing the seed, it's like offsetting it for some reason, but for our purposes it's more than enough. So What I want to do is do it again with a different seed. So this may be something reasonable like 6,000, and the offset might be 0.01. This might also be 0.5, one less, 1 O less, and this is also maybe 0.05. So this is basically just to create some interesting points for the Voronoi fracture, and that's it. I also use this technique because, yeah, I also use to merge these points, and it doesn't matter that they are connected, that these are lines. Voronoi fracture doesn't know that. So I'll just use a group node in here to make these a point group choice, and base group is disabled, and this can be by random chance. Let's just do random chance, and I will use also by bounding regions and save it just so I don't forget. Yeah, random chance. I mean, I want to create within this box, select some random points. So will you? Okay. Yeah, we have some. We have 50% of them. Maybe 50 is too much. Let's do 10 because they don't have that many points. This can be moved to the side. Yeah, so just within these points, let's just select some points. Yeah, this is good. And I would like to do point replicate in here to make 8 points and uniformly scale them in a sphere size around these points, but only do the chosen ones. So choice, and then keep the input geometry. Maybe add some noise to it. Maybe just a little bit further. And let's place this initial geometry in the Voronoi fracture and see what happens. Don't do interior pieces. And where is it? Okay, this is not the input, this is the input. So this whole thing should maybe go to the side. And in here we'll need some attributes. So I'll just do an attribute wrangle, and let's say this is rest and noise and noise, and this will be at v at rest equals at p, and at p plus equals to s noise of position times maybe 30 point comma 3 comma 0.6 comma 1, and these are some parameters for the noise. I don't really do noises in wrangles, but this is what Lewis did. So I am basically just taking this part from him. But this is really the simplest way to get this offset, this interesting offset on the points. And we are doing this because we want to have some deformation before the Voronoi, and then after we will be doing another angle that will revert at p equals at rest. Yeah, at rest. So, and let's update the normals. Yeah, and now, thanks to this, we are getting these Voronoi lines that are actually a little noised. And this is super interesting because I didn't know that we can actually influence Voronoi pieces like that. So let's see how they looks in exploded view, just so it's easier to see. Okay. And what this point replicate setup gives us is just that we just have a setup with smaller points around these big points, and just a little bit more variation on that. So yeah, this is it. And after this setup, let's just first of all make a group. And this will be kind of important. And let's call it edges. Let's call it edges. And this will be maybe group of edges. And not all edges. This will be just the edges that are unshared edges. Okay. Can you please preview it for me? Yeah. So you can see where this is going. These will become shortly the wires in between the edges that we have. Yeah, look at this. Amazing. Alright, so this setup can stay here. And now I'll drop down a connectivity node. And this is a little complicated because we will be dropping down tons of attribute promotes, but bear with me, this will end up being useful. So first I need a connectivity node, and this connectivity will be of point attribute, of point class. And let's measure the pieces. And this is a setup also from Lewis to use a fuse node in a very clever way to fuse the pieces that are too small into larger pieces. So this was very new for me, so I am also a little I am still a little like not used to doing it, something like that. But let's do this by piece and say name, because our Voronoi fracture gave us the names by default, I think. Yep, we have names of 117 pieces. So let's measure them, and then let's say split. And measure sub creates this at area, so attribute at area that is less than 0.001 maybe. So if you are a small piece, then get selected, and if you aren't, then it should be here. Yeah, so we have all of these small bits that are mostly my fault because of the because of this setup. But maybe let's increase this to be something like 0.2. So they will be bigger, and the Voronoi fracture will get some more space to create them. Amazing. So we are splitting the small pieces basically. That's just it. What we need to do is to add rename and delete their names. And then transfer attribute transfer. Geez, this is already half an hour. Okay. From the other pieces, we need to transfer the attribute name from the closest piece. So do the primitive and name, because attribute transfer always transfers stuff that is close by. And after this, I will promote attribute promote attribute name from primitive to point using the piece attribute of class at maximum. And this attribute promote is surprisingly versatile and useful. And I'll promote it back into primitives, from points to primitives. Now with just an average and without a piece attribute. So because this is maximum, we are just getting one value for any given piece. And that's good because we want them to get fused into just one piece. And now we need to merge, but just one. Oh, so this to the side, and then merge this with this. Wait, what? I should be merge this with this, right? With this. Interesting. Okay, merge it. So now we have attribute name that is on points. Let's do @promote it again. I mean attribute name that is on primitive, but every single small piece that we selected in here is have the same name as the closest big piece to it. And this will be important once we get to the fusing. So I will import, attribute promote class from point to primitive, because other nodes need it. And then I will use another attribute promote. This time it will be a different attribute. It will be curview. And we want this per piece from add class. Maybe it could be add name. We have both of them at primitive level. Maybe I could get away without this. Well, it's maybe not delete it, but let's try if we can get away with just the name attribute without using the class here. So do the name and change the name, don't delete the original, and call it umax. And this needs to be maximum. And with the other setup thing, we want to promote it, but this time as minimum, and call it umin. Umin. So I have two new attributes, and they basically specify the beginning piece, the beginning of the piece and the end of the piece for every single one of these pieces. And we'll be using both of them to displace them, to displace the position of those points along the normal. Okay, so we have human. Let's promote both of these. I told you there is going to be a lot of promoting in the setup, but this is actually surprisingly simple if you think about it compared to any other way to do basically this. So promote from primitive back to points, and it can be just the first match, whatever you find, then just pick it. And we have them on points. Great. I'll also promote the name. Okay. Let's do primitive name. Yeah. And finally, we get to the fusing. So what we want is to use the fuse, but there is this very handy attribute here, or parameter, that I did not know about, is that use the match attribute of name. And if you look at it, all of our small pieces using this are just getting fused into the nearest biggest piece because they share their this is what we did in here. Yeah, I'm sorry, this part of the setup is a little technical, and it's like maybe not the most fun to do, just dropping attribute promotes, but we'll get through it, don't worry. In this part, I'll drop a subdivide so we can get some nice geometry on the pieces. But for now, I'll bypass it because we don't need that right now, but it will be in this place. Let's take care so that we have some nice normals on points. I just want this to be here, and then let's do add VOP for attribute VOP. And let's call it lift cuticles. So yeah, this will be a milestone within the setup. This is a very important part. So first of all, let's bind, and I will just make sure that I did not delete the curve view at any point. Doesn't appear so. So curve view, and we also need the umin and umax. And umax. Great. Both all three of this. So first thing, I will do a ramp parameter from curve view, from the curve view, and then call it curve view curve u. Maybe not. Let's not use big capital letters in the name. curve view ramp. We technically can, but probably shouldn't. Let's call it nicely in the label. And just make it a spline ramp. And I would like to export this attribute from this ramp, this remapped ramped curve view, basically as an attribute that will be called scale blend. So if I go up here and press this, visualize my scale blend, and this is nothing too crazy for now. But if I start editing this, all right. So we can create an attribute that will be traveling along the geometry. And that's exactly what I'd like to do. So I'll just create an offset. This will be on point 1. And I'll just copy this parameter, paste it in the first one, paste relative reference, so they are at the same place, and minus 0.01. Now 0.1. So if I move this one, then the other one should follow, but it's not real time, but it does follow. So we can totally animate it. Yeah, go back. Go back, you point. Yeah, this is a very, very hacky way to do it. So I'll just Control Z, Control Z this, and let's just animate this point. I'll say at frame 48, you are here. Nah, value, leave the value as it is. Leave it here, and then at frame maybe 120, you will be at 1. So now if we look how it goes, we have this nice yeah, and how much I place it in here can become our offset. Maybe we want this longer, so this could be like this. But we need to be careful because with this super simple setup, it will always stay like this at the end. So I could just decrease the value of this point at the end. And maybe let's do that just to be super careful. So I'll just say I'll give a value of 1, and here you can just have a value of 0. So I'll be sure that it actually ends up being fully healed. And within the love cam, this is happening, yeah, almost off camera. So I'll just adjust the camera so that it doesn't get in there, but we'll get this later. For now, let's go back and start using the actual scale deformation. So what we need is fit range, and we want to fit the curve view in between the umin and umax. And this is crazy smart, but you will see why in a second. What next on, we need a ramp parameter, this one, and it will also be, let's call it ramp blend or something, or like shape ramp. this will actually be the shape ramp of the cuticles. What we want to do then is multiply this output with the output of our oh no, wait a sec. We want to do another fit and put this here and use the scale blend value as a destination max, because this will actually end up closing the deformation on the hair. It will end up collapsing and getting to its original healed position. So I'm multiplying the position by this and another parameter that is, let's call it disp mult for displacement multiplier, and it's also a spline ramp. I should really make that the default. I don't remember the last time I used it for coloring stuff. Yeah, so right now what we need, oh wait, this is not position. This should be the normal, and then we need to add that normal to position. So add it, this multiplied stuff in here, and output this as position. And of course, nothing happens as we expected, because all of these parameters are initialized to 0. So let's say this shape ramp and this displacement ramp. Ooh. Yeah, do it like that. And where is the disp mode? Ah, okay, I made the ramp just a parameter. Just a parameter here. And it will be disp mult. Disp mult. That's a lot of parameters. Okay. How this mode should be not too much. Maybe like point. And I made a mistake. Sorry for that. Because this umin and umax needs to go to the source min and source max. And their destination should be 0 to 1 for the ramp. Umin to umax. Ah. And this is why you need to be careful when you're creating setups. So now it works. And let's add this in here. And we can finally continue. So this parameter should be not this strong. Maybe let's do something like 0.125. And we have this, and our attribute already works. So it travels along the curve and closes the deformation, basically zeroes it out and closes our hair. Great. And great. Let's do poly extrude. In here, with super slight, maybe 0.5, and output back, another normal, This time we don't need it on points at all, so let's just leave it in vertices. So this will be out scales. And let's, by the way, just quickly change this here to out scales. And let's also look at this camera and just move it a little to the side so that our thing is happening off camera. Yeah, we'll be worrying about the rendering looks later. Alright, so we have this thing. So this is all of the hair setup done. Okay, so I ended up subdividing it at the beginning. So we have some more geometry. And maybe let's leave it at that. I'll see if it still bugs out on the lift cuticles. Yeah, appears to work good now. One more thing that I made a mistake also is that in this attribute rename we need to do it on the primitive tab or else it won't delete the name, and this is what was part of what was causing the problem. Okay, so this is the hair done. This is the hair done. Let's take care of the edges. So I'll go back to the moment that I did this group in here. I don't think I need the group in the main tab. So let's just leave it out here. I'll just call all of this, place it in a box, call it Lewis. Because this part is very much inspired by his setup. And yeah, this is no longer needed. Okay. For the edges, I just created this group that gives us all of the edges. So then I'm doing a convert line, convert line, in here, like that, just the edges group, much better. Remove unused points, and I don't think we need the rest length. Example. Okay, let's now just do a fuse. Fuse everything at maybe 0.2. So we have the points are a little bit more uniform. They are, because all of these points, every single one of these points got a line around it, so there is a lot of geometry on top of one another. So with this fuse, you can see we are getting rid of, well, most of it. And that's good. Now let's say polypath. just to connect endpoints and make our next sweep node, or wait, okay, this will no longer be needed. Oh. How did you manage to stay here, little guy? You know what, I'll delete this setup for now, disable, because the pieces are good enough. This was just something that I wanted to mention, and this is something that you could do, but apparently it's causing some problems. So let's just not do the additional points. Thankfully we have everything procedural, so this is not a problem. Okay. Right then, I would like to do a time shift and put it to our lift cuticles and time shifted by minus 30 frames, but $F minus 30 frames, and do an attrib transfer, this thing, and from this to the path I wanted the scale blend. So basically this will close and this will offset it in time. So both of these, and then transfer it to this. So these attributes will end up being in different places. But this should be already closed by the time that, yeah, maybe for this setup 30 is too much. I'll do 20. So first goes to the closing, and then there will be this on these actual cuticles, which is good. Then I will do a polywire, see if it works. Right now it's obviously huge, so let's make it 0.01, something like that. Uh, some more divisions, just so it looks better. Maybe then a smooth. Add the strength of 20. But don't you change my normals. And now I would like to do a peak SOP because of the extrusion that we did. These wires will end up being pretty much inside of the geometry, and I would like to move them up, but peak SOP is super strong, so let's do a very small value. Yeah, even smaller value actually. It should be here. Okay, let's not do big for now. We'll see how it looks. And yes. Alright, I'll just do another VOP in here and say this is alpha. Yeah. And I'll just invert the scale blend using a fit node. So bind, export, and bind. Probably should have used a wrangle for this, but it's okay. And this will be alpha with capital A. And then fit. The scale blend into this one. And this will be 1 to 0. So that it actually disappears as it goes. Before it is healed, when the scales are up, this will be invisible. So let's do null out line. Okay, but what we also need is those droplets that we have for and this droplet setup is pretty straightforward. So from here I'll do another group and to be a point group. Let's not bother with any name, a specific name. All that let's do, this will be a good practice. I'll call it drop, dorp, maybe drop. Yeah. So this will be drop, and I want to choose a region for it and make it smaller, base it off camera. Yeah, something like that. But again, I would also want to select some of them. Maybe really like a few. Right, let's do 0.5. No, 0.5%. And yeah. So I have 11 points selected. That's good. Next off, I will blast everything else except for my selected points. And here I'll do drop, delete now selected. So we just have these points that we like. And just in case of emergency, I'm doing an add. And I'll say delete geometry but keep the points. In case that we, for some reason, because of the randomness, selected 2 points that are directly next to each other and they have this connection still. So this is just a failsafe. Then I will do a wrangle and place some initial attributes on it. So I'll just copy the V. I will create a V vector attribute called orig p, and it will equal to p. So this is the exactly same as the rest attribute that I created. And then add id equal to add ptnum +1. So I'll call it init attributes, and after this operation, I will pick those points with pick sub at maybe 0.15 or 0.135. Why not? Let's see, does it work? And why won't you? Interesting. I know. You do not recompute the effect normals. Bro, you do not. And now it should work. Back to the peak setup. So now we have the peak, which is basically just offset by the normal. So it offsets the point. I will do it by 0.15. Very good. So all of them are offset by 0.1 from their original position. And look at that. We'll do an add VOP. Call it move offset. Okay. Close it. Close that as well. Let's start. First of all, let's do a mix node. And what I want to do would be the position. And do a mix between this position and bind. And put it in there. And say this will be orig b, a vector attribute. Yeah, so with this we can, yeah, it doesn't work in here, but if I would make a parameter, this would blend the points from their original position, now where they are right now, or where they was when I created the attribute in here before the peaking. So that would be this, and I will bind yet another attribute that will be scale blend, and I will use this value as the mixer output. Okay, maybe it does work. Yeah, so we have either at 1 we are at the oric p, or at 0 we are at the p that we are at right now, and the scale blend of course will drive this also, but right now we have the reverse of what we want, because they are first at the P and then they are at the other position, as you can see. So is making a subtract, and I want to subtract from RP this value. So this creates a vector pointing to RP basically, and it's scaled according to its length. What I'll need is a parameter in here, call it move parameter, get out the way, and then multiply the vector by move. I will use this value to animate it, I think. Ah, no, let's add to current position. So now we have them at, I will tell you exactly why I did it. So I was wondering why I forgot why I created this move attribute, but it is actually very useful because I could have just skipped all of this and remapped this value, and it would be that the point is here and then it goes down. But with this attribute, with subtraction of these two vectors, we are basically creating a vector that points towards the inside of our tube of our hair. So this move attribute allows us to push points inside of the geometry, and I wanted to do that because this allows us to hide those bubbles inside of the hair when they approach it, and not just get stuck on its surface and then awkwardly try to delete them with alpha or try to delete them with something else. Yeah, so that is why we do this subtraction and then multiplying it by the parameter. Well, let's leave it at up because this is not the end of it. What I also want to use this subtracted attribute for is to calculate its length, and I will do some fitting of this length, but in the end, let's do fit. Oh. And to do ramp parameter, call this one emission. Ramp may be emission yet, but let's just call it emission. Emission, spline ramp, and bind export it as emission. Okay. So firstly, I would like to just do the length. And as we can see, this is very short. This is exactly the same value as our peak value. So I would just fit this from 0.15, or I could even bind use the parameter from peak to make this more procedural, but let's not bother with that yet. And make the emission ramp out of that. So in here, we just have the value of yeah. So in here, let's make, there will be quite a lot of visualizers in this setup. So I'll call this one emission. And this emission, this can be a color, and do it ramped attribute between black to orange. So within this, pull it up. Yes, very good. But I would like this transition to be more rough. It should just become emissive, because these points, yeah, I like here they are 0, and yet the coloring is saying that they are, it's basically just wrong. But eventually you can see that they are all black, and some of them are starting to shine because they are starting to shine as they are approaching the hair geometry. So that would be it. And I will also just copy this setup and call this ramp p-scale, and this will be p-scale ramp, export it as p-scale. And this ramp I would like to do like that, so it can be more or less similar to the first ramp, like in here, but I would like this value to be 0.1 or maybe even 0.3, and here also 0.3. So they don't really disappear until 0, until they're gone, because we have this setup with the move with the vector, so they are hiding inside of the geometry. But this basically this p-scale ramp will allow us to scale these points once they are approaching the hair geometry. That will be getting smaller, but let's actually do that so that we can see it, so it will be easier to just wrap our heads around that. So let's do CTP for copy to points, and sphere in here. Let's get this sphere in here. It will be a very small sphere, 0.015. And let's just do 2, 1, 1, so that it's just more, so that it is just shaped like this. So that it has a certain shape that is elongated along the y-axis, and then UV texture will be okay, although I don't think I ended up using any UV stuff for it. Either polar or cylindrical should work. And fixed boundary seams. Maybe let's do polar. And normal. I did not end up using the UVs for it, but let's just leave it in here. Okay, so we have the points, and at first they're big, and then they are getting, I mean, if they are small, then they are getting big, which is the reverse of what we want. So I forgot to invert it in the fit, but that's easy fix. Let's just go here and say you are 1 at this point, and you are 0 at this point. So now we have them be big at the beginning and then get smaller as they are approaching our geometry. Maybe this shrinking is a little too aggressive. You can't really tell without doing a flip book out of that. Yeah, they are super fast. They should probably move slower, but this is due to the original scale blend. I could do an attribute blur to make it a little slower, but let's leave it as it is for now. One more thing is that is wrong is that they are all positioned exactly the same, so that's somewhat bad. And So I will create a attribute randomize in here to create an orient attribute for them. No, leave it here. It will be attribute orient on 4-dimensional situation, and let's do it inside sphere and cone angle and bias towards the n attribute. It can be something big like 130. So they are all like kind of random. No? I guess this can be disabled. But what also happens within our initial setup is that these points are slightly rotating, and I thought that this actually looks very, very nice in the render, that they are not just awkwardly standing still, so that we can get them some initial movement. So let's just do some even crazier stuff in here. So in here I will do something like that. I'll bind this attrib orient that we have now, attrib orient, which is super useful. I love this attribute, but it is a quaternion. This is a 4-dimensional vector. 4-dimensional vector, which has this super pretty color. Yeah, okay. And let's do quaternion to matrix. Easy, right? So it will create out of this quaternion a matrix. We don't need to get into the maths, what is happening under hood. Houdini will do stuff for us. So I want to use this quaternion attribute orient that is now a matrix and plug it into the rotate, and this will create another matrix to quaternion and bind export it back as orient attribute. And this will be vector 4. And let's see what happens now. Nothing too interesting, because we need some values in this. As you can see, this is actually somewhat working. Let's just slap the frame number into the angle, so they'll start and spin super quickly. So I will multiply that frame number by some timescale parameter, and put it in here. Call it time scale. I'm really bad at typing fast when I'm doing tutorials. Scale, time, scale. Yes, and put it, set this parameter to some really low value like 0.04 maybe. Boom. Is it good? They are rotating very tiny bit, but this is more or less alright. But right now they are all rotating on the same axis, which is not ideal. So I will just, but because even though I'm previewing these capsules that we made, we are operating on the points underneath. We need to remember that. So let's do a random. Not random, it's random. Yes, random. Easy. And this will be random out of a point number. And the random value I want will be a vector. And I would like to fit that vector because random value gives us only values from 0 to 1. And what I would like it to be -1, yeah, like this basically. Because we want the vector to go both ways, both 1 and -1. And I'll plug this into the rotate, and now we are getting a random vector of rotation for every single one of these. And this guy is flickering for some reason, but everyone else is pretty much okay. Yeah, this one is also flickering. And this flickering is created by something weird, probably, that I cannot comprehend at the moment. Yeah, but in the end, it should not be flickering. Okay, they are shrinking kind of fast, but this is basically how I did this effect, and it wasn't doing any weird shrinking back then. Yeah, the points, and because we used the initial lines for the points that we have right here, maybe this is too much of them. You can like pick them further or pick different points, but because they are the same and we are shrinking them back to their original position, they will always land perfectly on these lines, as which is what we want. Yeah, we can pick any number of random points. You could artistically control these and choose like very specific points. Maybe like hand pick them if where you want these the droplets to land. Okay. All right, so that would be it for the droplets themselves. But they are also, we are not done yet because now it will get even crazier. But first, let's do a trail stop and put it in here so we can have some velocity on the points. I'm blurring them ever so slightly during the render time. Yeah. I wonder why does it flicker now, but we actually created an attribute called ID, so let's try to use the ID. Maybe this is because the point numbers are changing for some reason. Yeah, now we are not getting any flickering, so I don't think the point number should be changing, but it apparently is. So let's just use the ID for it, and that will be a better idea in the end. Okay, yeah, trail stop creates our velocity, and let's do a null, drop down a null, and call it out droplets. To align the droplets to the value of these lines, we would have to do something like prem_uv and read the attribute tangent u on these lines and then drop them and then blended it again. But let's not make this even more complicated than it has to be. So right now I will do this. For the line, let's move this down. Do an attribute transfer in here, and I want some attributes from my droplets. So for this attribute transfer, let's just bring in the emission. Bring in the emission, and let's see it. Disable n with the emission. It should be good, although this is like that. Ramped point attribute min-max. I don't know, Blackberry. Yeah, basically all emission is 1 everywhere at this point because attribute transfer uses this distance, so it's something super small like 0.05 and blend value for 0.01. Let's see, now emission is somewhere is 1, somewhere is 0, so this preview doesn't work. Let's do auto and let's do auto. Yeah, now it works for some reason. Yeah, okay, so as you can see, we are getting some weird outputs for the visualizers, but it basically goes that when the capsules are starting to drop, boom, they are hitting the surface and create this attribute boom, 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 which is nice. This will mark the beginning of our Pyro source spread. Not Pyro source spread. Yeah. And in here, in the Pyro source spread, this is a super complicated node that creates a lot of crazy attributes. But it's actually insanely useful once you get to know it. So I'll just type in the values because I don't want to fiddle with it, because we can like make the expansion faster or slower based on everything. But what is the most important is just that I want to add here attribute called emission, because that's what I want to animate. And in the combustion, as the ignition attribute, I want this emission as well. Emission. So yes, exactly. For the fuel, I would like to do 0.4 and 0.14. You can do some noises. You can really play with this node if you want. The most important thing is that the ignition attribute is emission. So now if we start and first droplet will drop, and I want to preview the burn. Okay, so we have the burn, and now it starts to very slowly travel along these edges. And this is good. Let's see the camera. Maybe I don't need to adjust it too much. I'd like it to travel a little faster. because as soon as it hits, as the droplet hits, it starts to go out. So let's maybe do the temperature output, that will be bigger. And yeah, go back. Yeah, but it's kind of unfortunate that this is a DOP sim and you need to recache it every time. And probably there are way easier VEX solutions to make it more streamlined and without caching. But I kind of like this, you know, gives you some time to think. Yeah, so it travels kind of fast enough. Okay, I pressed the wrong value in the rate. It was supposed to be just 0.1. Now it will travel super fast. All right. Yeah, it drops and then boom, goes out. In the initial setup, there is also the gold coming from there. You could scatter points beyond and just do it like that if you want, no problem. Okay, but for some reason, this node, uh, hmm, hmm. Well, let's not overcomplicate it. Let's see if it works first. Let's do add blur, attribute blur. I'll put it in here. What I want to blur is burn attribute, which will end up as the actual emission attribute, even though we named the other one emission. But it will be the burn. That is the emission. Okay, and what we want to blur is, of course, the burn attribute. Okay. We have this, yeah, it created visualizer for us. If I blur it, doesn't work. We don't want to blur, we want to blur everything, including the border points. So, and connectivity is all right. So let's leave it at that. And then I want to do add delete, because we have now some all of these attributes from that simulation, which I don't really need. I don't want them to get in the way, so I'll just delete all of this stuff. Temperature, yeah, total burn. Yeah, this is not needed. And this should go back into the polywire. And after everything is said and done, right now we can't see the visualizers because the wires are too big. So I'll just do smooth shaded and we can see them. So that's good. And let's see if the alpha setup works. And it doesn't, because okay, this is also why the peak setup did not work here. But why are you? Oh, the smooth is way too strong. Okay, maybe like this, maybe even one, just so these connections are smoother. Wire is right, and let's see the outline and this alpha. What I would like to do would be to preview also the okay, because this was the initial setup, and after everything said and done it should be visible. But the problem is as I thought it would be, that this Pyro source spread is doing some weird stuff with my scale blend attribute. It's here, but it lost its purpose in life. It doesn't work that well anymore, so I'll just do an attribute copy, because we don't need to do transfer because this is the exact same geometry, and I'll just copy the scale blend from there so that it's beyond the scale blend. So it's not disrupted by this Pyro source spread business. And now with this, it starts to appear. And then with burn, it also starts to grow and glow, which is exactly what we want. Cool. So this is most of the setup done. Our tree is getting a little big, but there is actually one more thing to do. And it's not that straightforward as I thought. I will show you why. Yes, so let's go back to the very beginning and put a, or maybe just copy this resample. So yeah, like that and like that. So I will make it a little bigger, like 0.5. Not this way, like this, then do it clean. Alright, so we have the initial okay, we have just this tube. And it's exactly what we need. I'll make some point normals on it. So this node, point normals, no, compute, but make point on points, and group. And this is the case where I actually choose the points. But before we do that, what I want in this sweep node is to make it roll. Maybe not this much, maybe 1 and a and some more. No, leave the roll, and then I want to do maybe an angle like this one. And then within this group, I would just, I want to group points, and I would call this group rib source, SRC, rib source for ribbon source. And it will be, yes, base group, but I want exactly this point, and then I pressed Shift A and middle mouse button after selecting a point to select another one, and then middle mouse button here, and then middle mouse button again. So it's Shift A middle mouse button to create to group a whole basically edge loop around the tube, and that's it. Let's do this one. Okay. Let's maybe just select another one. So I'm using only Control Shift A middle mouse button. Yes, we have it. But I wanted it to be edges. So let's do it yet again. And here, Shift A, here. Now, here. Yes. Okay, we have it. Then blast. blasted, delete not selected, rib cert src, and we have our initial, our curve. Maybe I will try and twist it a little bit more. This is something that you can end up tweaking for days, like I did. But let's just continue with the setup. For this one, I would like to do add, and then I want to do a polygons and by group, and this just creates a line on our points, which was not there before. It creates this group, this beautiful curve. And what I thought I would do with this setup, this is pretty simple. I would just do a carve sub, carve, yeah, super simple. Yeah, because this thing can just carve a point. In here, and it goes bam. Yeah, so that's the animation, and then I will just append a sweep and make it a ribbon. Make it a ribbon. You don't need to do that because we'll delete this. And yeah, that's super cool. But wait, what's going on? First of all, this stretch around turn it off. But yeah, it looks good. But then when you start to animate it, it's whoa. So that's not what I want. And I did not find a way to fix it with sweep setup. And this is because carve sub creates, sweep node creates the up vector for the normal, that is the normal, and it basically keeps changing because it has an up vector that is somewhat weird, and when the carve sub just appears the point, then yeah, it basically messes everything up. So this made me like, okay, there is a problem. I need to figure something out. But in the end, I got it to work. So what we need to do is delete this carve sub. Let's just leave the sweep. And just to be let me just say here, we can add another resample if we have too much points. But I think it might be alright, but let's do maybe 05. Yeah, this will be enough. We don't need that many. And the sweep node can stay. So what we have is the sweep node with the ribbon here. This width can be 0.4, and it's actually super curvy, which is kind of bad. And I ended up using this row value to counteract on that. This is super interesting. I guess you could also do a custom shape using the second input, but let's leave with this for now, maybe -70. Because the slight denting is okay, but U is not okay, so I will leave it like that. and just do this at, yeah, like that, maybe even minus 90. So the ribbon is here. Okay, but how do we animate it? This is the main question. So first of all, I would like to make this just one column, or maybe two, but one is enough. Let's go back to the wire shaded so we can see them. And I ended up doing setup that someone taught me a long time ago when I tried to do the thunder, like expanding curve that would then end up being lightning. So we want to do this distance along geometry node, which is super handy, and I want to pick the first 2 points of the entire curve as start points. So this one, and it should be 0 and 1. Perfect. And output this distance attribute. And after this, what we need to do, as yet again, it would be easy in a Rango, but I like my VOPs because I can see everything clearly on the nodes, and I don't know, I like that. So let's do carve by dist. And this thing, we will bind the dist attribute created by the previous node, by the distance along the geometry, and parameter, and that will be maybe threshold. And I want to compare. So a distance, are you greater than the threshold? And if you are, and you better be, if you are, then remove point. And that's basically all we need to do. But I need to put this into the condition, put the condition into remove point, and the ptnum for the points. And now if I start moving this threshold around, we can start deleting our points, but I need to preview it first. Okay, leave it at 0, so we have only these two. I guess at point 1 we don't even have these. And then pum 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 pum. It starts to whoop whoop unroll, and the construction of the curve is constant because it's already there. So that's amazing. It will serve us a good basis for what we do next, because we also need some emission attributes. So let's do a subdivide, and here maybe this should probably be some more times. Yeah, super dense geometry. Super dense geometry. Yeah, this setup is a little wonky, but it works. So it is what it is. So what I need is animation on this threshold, obviously. So let's do minus 0.1. And I'm getting some errors, so let's save it just to be sure. It's mad at me because it deleted everything, so let's just leave these two. They are off camera anyway. And let's look at the camera, see my initial scales, and this ribbon should flow after they are somewhat closed. So let's start it at 110 and then make it fully come around at 168. So 110, you're 0, 168, you are 1, or even more, because this threshold, yeah, measures the distance. So you can be even further. Say you are 3. So we're like, whoop. You can resample it differently, maybe, or just get rid of this resampling whatsoever. And because we are going from the start to finish, the start is staying 0 and 1. We don't need to adjust that. This subdivision is probably too much now. Let's maybe do it 2 for now. Because I want some geometry along these lines. And this is why I probably should do a line here. Let's just try it quickly. Do a line, make it a second input cross section. And this is super interesting. Make it along the Z and 0 along the Y. Or maybe along the X and 0 along the Z. But then I need this to get rotated. Well, how can I rotate it? This needs to be 1. Needs to go on this one, but it needs to copy this parameter, paste it in here, make it negative and times 0.5. So it's in the center. And this is crazy, but somewhat working. This row is probably unnecessary now. Don't do it. Is it just too long? No. I need to make a transform and rotate it so it looks good. Finally. As long as it's 90 degree. Oh yeah, now we have it. That's interesting. The U-turn is caused by the difference in these two curves. But why is it like that? Again. Okay, let's just do roll again to counteract that. Apply the roll and make it minus 75. So we have it, what we had in the beginning. The very stretch around turns can break it badly. But apparently it can also fix it. or not. Let's do just a subdivision and continue without further ado, because this is getting super long probably. Let's do group, and this will be one that we already know. It's edges, call it edges, disable base group, and enable by edges, unshared edges. So now we get these outer lines, and that's good. I'd like to do convert line, make it only the edges group, and don't need the rest length, so don't bother with it. Okay, so this is for this purpose. Then oh no, this is good. Now what I need to do is dissolve, and what I want to dissolve is this group edges, but actually dissolve everything that is not the edges group, and this way we can get another geo for just the edges of the ribbon, because they are shaded a little bit differently. Just a little bit differently. All right. Let's do attribute create. On these, because this setup is, I should be, I guess, explaining it more step by step and with rendering in the meantime, so it would be easier to follow. Attribute transfer, because I didn't came up with all of this at the same time. So I'm making these the attribute of emission, and it should be a value of 1, but default of 0. And then I'm transferring it to this ribbon, and this is why I need these. This is why I did this line setup. Now I can do 10, and this is perfect. Okay, let's leave it. This is perfect geometry now. It's even better than in the initial setup because of this line. We can have now on these points of the geometry, we are having this attribute emission, and here transferred. Let's do less, and what I want to transfer is emission. Alright, don't do this, do this, and please show it to me. This is bad. Why are these? Ah, okay. Yeah, this is another effect because if this is not just 2 points, then this deletion is not mm, streamlined because right now it's just like this. But if we have more points, like 4, then it starts getting steppy, which is downside. I mean, this could look good, no worries. If you want to make a but this if an effect like this one, it's totally valid, but it just wasn't so in the initial reference, so I'll just stick with this and do some crazy resample after this and do resample here 0.05 yeah, because this subdivision gives me the proper geometry. Maybe you can just select different source points and it would work, but I just didn't want to be bothered by it no more. So right now it's probably appearing a little steppy, but I don't think you can notice even if it's going super fast. Yeah, so transfer the attribute of emission. So some of them are getting a 0 and some of them are getting a 1. And why won't you work? I've just disabled, of course. Yeah, this is exactly what I want. It should just be around, yeah, like that. So let's do 0.05, even smaller, and then blur it. Because I want this this to glow. It's actually glowing. So emission, maybe 15. You can pin border points or not. Whatever gives you the best results you're going after. Okay. And this would be no. That is called out ribbon. Ribbon. Or ribbon. Ribbon. And what is also needed still will be this setup with the edges because they are actually a separate geo. They will be called ribbon edges and they are glowing in a different way and then getting scaled. So let's copy this group setup and this dissolve. And do attribute transfer. This and this and here. So this is where I create the edges, the actual edges, and this edge, this will be necessary in a sec, because here I want to do dissolve selected. Right. And Yes. A resample. L5. Because this dissolve selected gives us just the end edge. And I will use this end edge to transfer some attributes. So let's just steal this attribute create. And also like that. And copy onto this thing the emission. And do super small value. Yep, super good. And then do add remap. Just copy it again because I want them to be a little different. So this one can be 0.01 and this one can be 0.02. Remap this one from 0 to 1 to 0.001 and 0.004. And new name would be width, and the point original name is emission, and this original emission, blur it, blur it, and do attrib copy, attribute copy, into this, steal the width, because you don't want to merge them, because that would multiply, like get another geometry in there. We just want the width attribute. And of course, polywire. You could also do it with a sweep, but polywire is way better for this particular purpose. Let's make here and polywire. I don't know if polywire is yeah, we'll just use this and say with width and get maybe 1 in here. So now, as you can see, these ends are bigger. Let's maybe blur this one as well. You blur emission 20 and copy it here. Would that work? Because you only later do it like that. See the polywire with now. Alright, let's make you a dedicated blur for the width. And this will actually be out edges once I get this attribute right. So I do want it to be emissive in here. and it's not. So maybe make this to 0.1. Yeah, that's better. Maybe make this to 0.1 as well. And then with this blur, disable these border points. So this part will be glowy. And in here, we have the emission. Let's do the width. Oh, because I can't see it. Let's go back, make it emission back. Yes. Yeah, I'm just controlling these two separately because I wanted them to have a little bit of difference, but you could totally do it like that and be done with it. Or just even write emission into this and it would still work. So let's see how it looks. What I want to end up with this is that it's a little bit more wide at this end, and then it gets thinner. What I don't get is why this last edge is getting deleted for the most part, because I fixed it somehow. And let's see how I did that. Was it in the dissolve? So this is the initial setup. Connect path. No. Ah, I'm making it like this. And this is how you can do it. Yeah, don't ask me why this works, but it does. So now when you dissolve the points, the finish line. Oh wait, what? You selecting the edges, you doing this. Yeah, remove unused points. Very good. Then you do the dissolving. And then we have the basic setup for this edge, and the last one is not getting deleted no more, which is exactly what I like. And now when I started doing the tutorial, I saw that this corner here is just a little bit rounded. So let's try and do that on the fly. Maybe I could do it with a bevel. Or maybe not. Let's try just a smooth in here before we do it. So I'd like to smooth the position, yeah. Interesting. Let's see if blurring the attribute P will give us a better result. All right, let's get on with the shading. But before I do that, I'll just make the background geometry just super simple. So let's do geo, and this is BG. And what I like to drop is just this softbox of AE quick softbox. If you don't have that node, because this is a part of the AE lib package, which is a very good package of nodes, totally free for everyone. So you should probably get that. But you can totally model a geometry like this one. This one just makes it simpler. So I'll make it now, output it, and what I want to output would be move it down. Don't output the back, just output the right. Yeah, like that, and maybe scale it here. Pretty good. No, wait. Where's the camera? The camera doesn't care.